This is the second method to predict the direction of a spontaneous change, because it is a subset of the fourth method. Therefore, I'm not going to spend time to explain how to use the second method. Now let's look at the fourth method. The fourth method is to use delta G to predict whether a process is spontaneous or not. When delta G is less than 0, the process is spontaneous. There are two ways to use the fourth method. The first way is to use the combination of delta H, delta S, and temperature to predict. The second way to use the fourth method is to use the standard Gibbs energy of reaction to predict. Now let's look at the first method to use the combination of delta H, delta S, and temperature to predict the direction of a spontaneous change. Well, let's put down the relationship between delta G, delta H, delta S, and T. Delta G is equal to delta H minus delta S times T. You can also write down delta G equal to delta H minus T times delta S. It's the same thing. This one is more common. Now let's consider different scenarios. Delta H can be positive, can be negative. Delta S can also be positive, can be negative. Therefore, there are 4 different combinations of delta H and delta S. Let's talk about them separately. If delta H is positive, delta S is positive because temperature is always positive. You cannot have a negative Kelvin temperature. A positive number multiplied a positive number is equal to a positive number. A positive number minus another positive number. Depends on which one is larger, delta G can be either positive or negative. If you want to make delta G negative, you prefer a higher temperature to make the second term larger than the first term. Therefore, at a higher temperature, delta G is negative. It is spontaneous. Let's look at the second case. Delta H is positive, delta S is negative. A positive number multiply a negative number is negative. Minus a negative number is positive. A positive number and another positive number make delta G always positive. That means it is always non-spontaneous. Let's look at the third scenario. Delta H is negative, delta S is positive. A positive number multiply a positive number is positive. Negative number minus a positive number is always negative. Therefore, it is always spontaneous. Then let's look at the last scenario. Delta H is negative, delta S is negative. A negative number multiply a positive number is equal to a negative number. Minus a negative number is positive. The first term is negative. The second term is positive. Therefore, depends on the absolute value of which one is larger. This one can be positive or negative. At lower temperature, delta H will be larger than the second term in terms of their absolute values. Therefore, delta G will be negative. It is spontaneous. This is non-spontaneous. For the first case, the reason we can make it spontaneous or we can make delta G negative is because of the second term. Because the first term is positive, it doesn't have any contribution to the negative of delta G. Therefore, in this case, we call the process is entropy driven. Similarly, the last case is called enthalpy driven because the first term is negative to make delta G negative. The contribution factor is delta H, enthalpy. Therefore, we call this enthalpy driven. Mathematically, we can make a plot for this equation and predict when delta G is positive and when delta G is negative. Let's look at the plot. Well, these are the plots. The intersection with this y-axis is called y-intercept. If you write down the equation, it should be y equal to mx plus b. Let's put down the delta G equation in the same format as this one. Delta G equal to negative delta S times T plus delta H. So in other words, B is delta H, and negative delta S is M. M is the slope. B is called the y-intercept. Then let's try to match the previous scenarios we talked about. So let's look at the first line. The y-intercept is positive. That means delta H is positive. And then the slope is negative. Therefore, delta S is positive. At high temperature, it is spontaneous. Let's say if this is the same conclusion we get from the previous analysis. Positive, positive, high temperature. Positive, positive, high temperature is the same thing. Then I think you can finish the other analysis for 2, 3, and 4. For number 4 is, for number 3 is, we're done.